So in our last class, we were discussing about the proportionality development from the equations of motion. We developed two set of equations, and the class finished in the process. So we're gonna take a quick recap for what we did in our last class, and then we're gonna go take it from there. So first, to start off, we have four equations of motions: v equals to u plus at, s equals to u plus v divided by 2 multiplied by t. Number 3 is s equals to ut plus half at squared, and number 4 is v square equals to u square plus twice as. Now, key point is acceleration is to be constant for all of these equations to be applicable, and by taking acceleration out, by applying appropriate scenario to individual equations, we can make them into some proportionalities. Because equation number 2 does not have acceleration involved within here, because these are only this equation only deals with the variables displacement, initial velocity, final velocity, and time. So we cannot make any proportionality out of this one. So this is not going to be helpful for proportionality development, but we can use all the other three for individual scenarios. So if we take the first one, the idea was that the first one was v equals to u plus at. We can go for two different scenarios. First of all, if we consider the object was the first scenario, if object is starting from initial velocity 0 or object is starting from rest, in that case we can write v equals to at. Taking acceleration as a constant, we can write v proportional to t. So this is the proportionality application for between final velocity and elapsed time. The second scenario can be if object is decelerating, which means object did have some initial velocity and then it decelerated to rest, which means the final velocity is 0. In that case, I should write if final velocity is 0, then we can also write 0 equals to u plus minus a into t. We are writing minus a over here because if the final velocity has to become 0, then the object must have negative acceleration or deceleration. So if we change the sides out of this equation, we can get u equals to at, which ultimately brings us u proportional to t. So what you need to understand for this equation for u proportional to t, I mean, this might actually give you the idea that initial velocity is proportional to time. That might actually look a bit odd, that initial velocity of an object is supposed to be defined quality at the beginning of time. So how can it be proportional to a certain amount of time? Because final velocity proportional to time makes sense. I mean, we start an object. Let's say if I try to show you the visual representation for the first logic, let's say an object starts from rest, u equals to 0. So it goes forward and it slowly speeds up for bigger and bigger final velocity. So the more time it passes, the more final velocity it gets. Then what would this equation actually mean? What we need to understand that this proportionality actually tells us that if multiple objects are undergoing the same amount of deceleration, all of which started from different initial velocity. So one way to represent this scenario is, let's say I'm going to show you some numbers. Should I show you some numbers? Maybe not. Let's say there is an object right over here which is going towards this direction at an initial velocity of, let's say, u1, and it's gonna continue its journey with a negative acceleration minus a throughout its journey, and eventually, let's say, it's gonna come to rest right over here. This is the final point of motion where v equals to 0. So as the object goes forward, its velocity is gonna slowly become less and less and less, and eventually it will become 0. So in this case, the condition is final velocity should be 0, which means if we observe for the initial velocity for different duration of time, starting from the final velocity backwards, which means, let's say, if we say the object takes, let's say, from this point to reach all the way up over here, the object takes t1 time. Let's say from this point, object takes up to all the point over here, let's say the object takes t2 time. From this point, let's say the object takes all the way up to final velocity 0, t3 time. So if we have all of these individual different time amounts where the observation, the total duration of the observation of the motion object, moving object, is considered to start from multiple different locations. That's why we have different individual time amount for the initial velocity to ultimately reach to 0. This would mean that if this is u1, let's say if this is u2, if this is u3, and so on and so forth, this proportionality dictates, this u proportional to t, this proportionality dictates that for all of those cases, this proportionality will hold true. U1 by T1 equals to U2 by T2 equals to U3 by T3, so on and so forth. So that's the idea for the second proportionality. Equation number 2 doesn't give us any proportionality because that doesn't have any acceleration. If we go for equation number 3, we have displacement equals to ut plus half a t squared. Now you can see that we don't have final velocity within this equation, which means we can only get one proportionality out of this equation, which would be if we apply the logic that if the object starts from rest or if initial velocity u equals to 0, that would give us s equals to 0 into t, no, 0 into t plus half a t squared, which ultimately brings us s equals to half a into t squared. We're going to consider this whole thing as our proportionality constant. So if we take the total half a as a proportionality constant, we can write s proportional to t squared. This actually brings us the idea that if an object starts from 0 initial velocity, let's say u equals to 0, and the object is going to go forward with a constant positive acceleration a, which means the object is going to slowly speed up, the covered displacement would be directly proportional to the time squared. So if let's say if the object travels up to this much distance, let's say this much gap is s1, and to reach to this point, required time from the beginning is t1. And let's say from the beginning, the object travels a further distance, let's say up to here. Once again, let's say from the beginning, this distance is s2, and from the start, let's say this amount of time is t2. And we can actually go for multiple other variations over here. If we go for all of these variations, this proportionality dictates that all the ratios of displacement over time squared, so s1 divided by t1 squared, this is the this is the proportionality for the first scenario, should be equals to s2 over t2 squared, should be equals to s3 over t3 squared, and so on and so forth. You can apply all of these equations for here. There's a third case, proportionality. If you go for the fourth scenario, similar case, we have v square equals to u square plus twice as. So the first logic if u equals to 0, which means if the object starts from the rest, then we can write v square equals to 0 square plus twice as, which can be rewritten as only twice as. If I take that 2a as our proportionality constant, ultimately we get v square proportional to s. And also, if we consider the object is undergoing deceleration with some measured initial velocity to begin with, which means the final velocity is 0, in that case 0 square equals to u square plus 2 into minus a into s. We are using minus because this is in the opposite direction of initial velocity, which ultimately brings us that u square equals to twice as, this part being the constant. If we take it out of the equation, we can write that u square will be proportional to s. So we are actually getting 5 different proportionalities out of these 3 equations, and these proportionalities are inherently related and they are directly convertible as well. So if I just summarize this whole thing, if I have give a larger view for all the proportionals that we have, okay, so we have v proportional to t, u proportional to t, s proportional to t square, v square proportional to s, u square proportional to s. So writing these all up within a single location, so we have this for positive a, and then for positive a, and then for positive a. These 3 for positive acceleration, and for negative acceleration for cases where object ultimately reaches to rest, we have 2 proportionalities. We have u proportional to t, and we have u square proportional to s. Now, the reason I told you that these equations are inherently related, or they are congruent, or they are agreeable among each other, is because you can see that v proportional to t and s proportional to t squared. So if s is proportional to t squared, which means by means of the idea of proportionality, you can replace in the within the proportionality equation t square as v square, because the idea is that if you have an equation, I mean, if v proportional to t and which means t proportional to v as well. So if s is proportional to t squared, you can replace this t with this v as well. So that would actually ultimately give you s proportional to v squared, which is basically the third equation that we have. So these equations are correlated and can be of useful. If you actually have a bit difficulty to remember how this equation, how this proportionality is to bring about, it's not a big deal. The easier way to remember is that you have to consider either the initial velocity or the final velocity to be zero for this proportionality to come into existence, and then take out the acceleration or any other numerical multiple that you have. For example, in the third equation, we had the proportionality that to be half a. So only acceleration was not the constant. Together a by 2, half is a numerical constant. So you can use it as a part of the constant as well. Half a was taken as a numerical constant, sorry, proportionality constant, and we ultimately got s proportional to t squared. In the other hand, whenever we go in for the fourth equation, twice a was considered as the proportionality constant. So that's pretty much how this whole thing works. Now, why am I showing you this? Because these proportionalities can come handy if you know how to use them in appropriate scenarios. Let me show you how this whole math could be done. Have a look over here. This question number C says the total distance covered if initial speed was doubled. How much would the total distance be if the initial speed was doubled? Now, this is the part that I need all of you to understand, that for this scenario, whenever we considered total distance covered basically means, for this case, the stone is supposed to go all the way up, reach the maximum height, and eventually fall all the way down as well. We have to have both of these, we have to consider both of these motions of journey. So we could simply go by calculating this whole variable by simply considering 20 meters per second. But if this scenario was only for one way, let's say what would be the maximum height if the initial speed was only doubled? For this scenario, try to understand. For this scenario, total distance covered scenario, none of the initial or final velocity is actually zero. Try to understand, because total distance covered essentially mean which part of the motion, or for how much segment of motion are we talking about? We're talking about as the initial velocity of the object initially was 20 meters per second going upwards. So let's say that is positive, and the object reaches all the way up, reaches a zero velocity over here, and eventually as the object goes down, it reaches the same starting point over here, at which instant its final velocity is minus 20 meters per second. So for this observation duration, or this much time, none of the initial or final velocity is actually zero. That's why we cannot apply the proportionalities over here, but they can be handy in other cases. So finding out this number is actually pretty simple. We can simply go by the basic rule that we have gone in the earlier scenarios. For number C, we are going to write u square, initial velocity u would be 40 meters per second. The acceleration is a default minus 10 meters per second squared, and we are trying to find out the total distance covered, s equals to what, in which case the final velocity should be minus 40 meters per second. Now this should be minus 40 meters per second because we know this is supposed to be minus 40 meters per second. So we're going to place all these numbers over here, try to find out the value of s. So this is given by v square equals to u square plus twice as. Let's place all these numbers. Minus 40 whole squared equals to 40 squared plus 2 into minus 10 into s. So this is not helpful, is it? It is 0 হয়ে যাচ্ছে না? displacement is supposed to be 0. The question is asking us to find out the total distance covered. My bad, I messed up vector and scalar. Happens. So this was distance covered, but this s in the equation is not distance, is it? What is it? This is displacement. So if I apply this formula, ultimately s equals to 0, because displacement is supposed to be 0 when the particle still reaches at the same starting point of the motion and initially is going downwards at 20 meters per second. So obviously the distance is supposed to be 0. That question didn't ask me to find out the displacement. The question asked me to find out the total distance, which means I cannot do this math with this formula. Not gonna work. I have to find out what is the distance covered from the start point all the way to the maximum point, simply that, and then multiply that whole thing by 2. So I cannot do this in a single method. Okay, I can work with that. So this method would not work because as a vector quantity, that displacement is 0. So this equation is not of requirement for us. So let's go for a different color. So let's say currently we're going to observe the mission, observe the motion. Yes, we can use the proportionality in this case. Earlier, I tried to solve this problem with the proportionality because I thought that this would be possible. But as I can see right now, that because this is the distance part, I cannot actually use the use the formula directly for this case. But now I'm going to go for the proportionality. For example, for this part of the motion, the final velocity is supposed to be 0. And as we've seen in our earlier class, that the height covered when the object was shot at 20 meters per second, the maximum height covered was how much? Can someone remember? What was the answer of A? Maximum height reached? Etar answer কত ছিল?
20 meters.
This was 20 meters. So for this scenario, we can actually start applying the proportionality, because if we simply try to find out the new height, let's say I'm going to write it in this format, that u square proportional to s, because for both the initial and the final height, the final velocity is 0. So s in this case is the displacement of the object only for the upgoing motion, not including the downward motion, because we're simply going to multiply it later. So if I just use the proportionality over here, we can go by u1 squared divided by u2 squared should be equals to s1 by s2. How am I going to replace those values? So let's say in the initial case, when the speed was 20 meter per second squared, the total maximum height from start to the maximum position was only 20. So I'm placing the values of u1 and s1, pair values. And then I want to find out s2. So I'm going to write s2 as s2 over here. And the second case, initial velocity would be double of 20. So this is going to be written as 40 squared. So now this math will work out just fine. So s2 will be equals to s2 equals to 20 multiplied by 1600 divided by 400. 0 0 0 0 bad 4 4. So ultimately we're getting 80 meter. That's basically it. So that's how we can use the proportionality equations to find out a third variable. If you don't want to use this proportionality, or if you forget about this proportionality, no big deal. This same math could be done by applying the same initial logics as we've done earlier. So you could go by this proportionality logic, the part that is written in red, or alternatively, you could also go for the part that I'm about to write with green, is that you could directly write this equation that v square equals to u square plus twice as. Okay, 80 meter is not your answer, by the way. 80 meter is not your answer for C, because in question number C, it asked you that what is the total distance covered if the initial speed was doubled. Total distance covered means the total distance it covers starting from the point, going all the way up and eventually falling all the way down, which means the journey has to be covered twice. This was the found distance only for one way, going all the way up. So the actual answer for this, why is it 8? What did I do wrong? Achha. The total journey is actually should be for 80 meter. So this is the 80 meter is the height covered in one way going up. So I should write total distance, total distance equals to 2 into 80 meter gives us 160 meter. So that's how we can do this. If you forget this proportionality equation or feel a bit confused that which one to use, because we had 5 of those, if you are, it's no big deal. You can directly go by the application of the formula as well. But then again, you have to apply it for half the motion. I mean, let's say one going upwards, and then multiply the total displacement by 2 to find out the total distance covered. So that would be pretty simple. You can simply write 0 squared equals to 40 squared plus 2 into minus 10 into s. If you calculate this number, your s would be equals to 1600 divided by 20, still gives you 80 meter. So that is also possible for this value to work out. And then you can directly go by to calculate the total distance, which would be also 2 into 80 meter. Ultimately, it gives you 160 meter, which is your final answer. So there are multiple different ways to approach a certain problem. If you know different ways to solve a problem, you can choose smartly in cases where you have to save some time. If you wonder that we are able to do the problem very easily by this equation, so what's the whole point of learning the proportionality? I mean, why should we do this? Well, here is the catch. Let's say this was a scenario where the acceleration of the object was not given to you. Let's say initial acceleration was not given to you. But the question already told you that for a 20 meter per second, 20 meter per second speed, the maximum height the object reached was 20 meters. This question value was already given in the question. Going for this proportionality equation actually helps you to bypass, or you can skip calculating the acceleration of the motion. You can see over here that we have used the proportionality equation by skipping the use of the proportionality constant of the equation, which was twice a. So we didn't bother to calculate that. Rather, we brought in all the variables which are related to each other in a proportionality manner, and then placed all these numbers to directly calculate the height. So if the acceleration was unknown to you, which is not the case for this math, but if it was unknown to you for a certain given case, then this would actually help you to solve the problem a bit more faster. Faster problem solving can be a pretty important idea, especially in MCQ question solving, because I personally feel that students should find the least time consuming method to solve any MCQ paper, any MCQ question. They should know this at least, but which one should they adopt in the exam hall is totally dependent upon whatever their brain delivers them. So let's say you read a question through, and the first method that comes in your head, which should be logical, you should try and be able to solve the problem with that method. You shouldn't try to think about multiple different scenarios and try to solve the method by judging multiple different ways. You should be judging that which should be the least effortful way or least time consuming way. That actually consumes more time. So you have to build up the practice to choose the least time consuming method to solve an MCQ paper before actually appearing the true question. So okay, Ryan asked me a question that how are we sure that the stone comes to rest after coming in contact with the ground? We don't know. The stone might be coming to rest after contacting the ground. The stone might actually bounce off. To be honest, for the scope of this question, we are not even bothered for what's going to happen after the contact with the ground. Our observation is limited from the instant the stone is thrown upwards till before the stone touches the ground. That's why I wrote over here that the final velocity of this up and down motion is considered to be minus 20 meters per second. I didn't write this as 0 meters per second because I'm not assuming that the stone will come to rest. When the stone will ultimately hit the ground, there will be new forces involved because the stone will then hit the ground. So the ground is going to hit the stone back with a certain amount of decelerating force. The stone will have its weight working on itself, which is a by default force. Together, they will give a resultant force on the stone. So we're going to have a different set of acceleration. So that for this whole part of the motion, which was happening within atmosphere, we consider the acceleration was only minus 10 meters per second squared because we are ignoring air resistance. But when the stone comes in contact with the ground, its acceleration will no longer be 10 meters per second squared, which means this is going to be require a totally new set of equation build up because acceleration would become different. So we do not know that, and for the scope of the question, we are not even bothered for this. For our observation, the final speed of the stone is minus 20 meters per second. That is as the stone reaches the initial starting point going downwards. If it immediately touches the ground, it's going to start experiencing a reduction of velocity, but we are not observing through that journey. We are observing the motion right up to the point it touches the ground. Do you understand the borderline? Got it. Okay. Any questions so far? Anyone? Anything?
Sir.
Yes.
I joined like about 5 or 6 minutes late, so could you feed me the first and third formula?
The proportionality or this one?
The proportionality, sir.
Achha. The first one is actually built up on the first equation, which is v equals to u plus at, the very first equation. Here, acceleration is going to be taken out as a proportionality constant. So if we want to get a proportionality equation, we can apply two individual logics one at a time. That if the object starts from rest and undergoes a positive acceleration, so we can then write v equals to at because u becomes 0. So I did not bother to write this over here. And taking the acceleration out of the equation as a constant, we can write v proportional to t, which means if an object starts from rest and goes forward with a constant acceleration, and if we observe the motion of the object for different time durations starting from the beginning, then at any point of motion, the final velocity of the object will be directly proportional to the time that it is required to travel to that location. That's what it means, v proportional to t. Alternately, if it so happens that an object had some initial velocity to begin with, it undergoes some deceleration and ultimately comes to rest, which means if the final velocity of an object can be defined as 0, in that case 0 equals to u plus negative a into t. So that is our equation, so which gives us u equals to at. Ultimately we can convert this into u proportional to t, which means that as the object goes forward and decelerates, how much time is it going to require to ultimately reach to rest is directly proportional to its initial velocity. If it starts with a bigger initial velocity, it's going to take proportionally longer time, and vice versa. বুঝা গেছে?
Sir, could you explain the number 3?
Yeah.
And
Sure.
also, sir, can you explain me why the second formula is not included for proportionalities?
Oh, because for these logics to be applicable, we are considering the motions under premise that the motion is happening under a constant acceleration. Equation number 2 doesn't have the acceleration within the equation at all. It is only built up with s, u, v, 2 or t. We cannot take out any of these variables as a proportionality constant because none of these variables are supposed to be constant as the object goes on forward for our observation. I mean, if you start your observation at some point and the object is moving in one direction, your displacement would be variable, your initial velocity can be variable, your final velocity can be a variable, your time can be a variable. So because acceleration is not involved in this question, that's why no proportionality could be derived out of this equation. What is happening in number 3, s equals to ut plus half at squared. This is the equation, this is the equation, and because this is the equation for the displacement going forward, and we only have initial velocity u over here, so we can only apply the logic that initial velocity u to be 0. So we don't have v over here, so only one proportionality could be derived out of it. So if we apply initial velocity 0, which means, let's say for a scenario when the object starts from rest, in that case s equals to 0 into t plus half at squared. Ultimately you get s equals to half a into t squared. Taking the half a as a constant, we can get s is proportional to t squared. This actually means that if an object starts from rest and goes forward with a constant acceleration, the displacement is going to made over multiple durations of time. If we observe the motion for multiple durations of time or different durations of time, that displacement will be directly proportional to the time requirement squared. So if it travels for double the time, it's going to cover 4 times the distance. If it travels for triple the time, it's going to cover 9 times the distance, so on and so forth. বুঝা গেছে? That's it.
Yes, sir. বুঝা গেছে।
Beautiful. Yes, Naima, I can actually show you the fourth equation as well. The fourth equation is also pretty much based upon the same premise that b square equals to u square plus twice s. So if we apply it for initial velocity 0, we are considering for a positive acceleration, which means the object is actually speeding up. So object will start from rest and slowly go forward and speed up. So we write v equals to v square equals to 0 square plus twice s. We actually converted the u into 0, and plus twice s is the twice s. 0 square is left out, so ultimately we get v square equals to twice s. And if we take out the 2a as a proportionality constant, all of it, so ultimately we have left v squared right over here and s right over here. So that gives us this proportionality, v squared is proportional to s. This actually means that if an object starts from rest and goes forward with uniform acceleration, and if we observe the motion of the object for multiple different distances covered. So let's say the object starts from position 0. Let's say we measure the final velocity after 10 meters, we measure the final velocity after 20 meters, we measure the final velocity after 30 meters, so on and so forth. If we have the measurement of final velocity and relevant displacement for multiple different places, then all of those final velocities would squared would be directly proportional to distance covered. This actually means that s would be directly proportional to velocity square, final velocity squared, which means location where the final velocity is okay, that's it, wait. It means that location where the final velocity is double compared to a certain number. For example, if I just try to draw it for you for the physical explanation, let's say an object start at 0 velocity. So initial velocity is 0, the object starts from here with a constant positive acceleration to the right. So it goes forward just like that, goes forward like that. Let's say we have a location right over here where the final velocity is, let's say, 10 meters per second. Let's say right over here we have another location where the final velocity is 20 meters per second. Let's say we have another location somewhere on the right. This figure is not drawn to scale, so don't disregard the distances. They're not supposed to be equal. I'm going to show you why they are not supposed to be equal. So let's say over here the final velocity is 30 meters per second. So if this distance is, let's say, our s for displacement for 10 meter, this whole distance is displacement for 20 meter per second speed, final speed, and let's say this whole distance is, let's say, this whole distance is the relevant distance for the 30 meter final velocity. So let's say this is the distance required for 30 meters per second final velocity. This equation actually dictates that for all of these individual variables would be related to the square of the final velocity, which means the distance s10 and distance s20 would be relevant to the square of the velocity, which means if I were to write that v square proportional to s, or I could make up this into a proportionality equation. Let's say 10 square divided by 20 squared. These are the two final velocity ratios squared should be equals to s10 divided by s20. So which ultimately gives us that s20 should be equals to 4 times as much as s10. What I'm trying to show you is the total distance the object would cover to reach this double final velocity would be 4 times as much compared to reaching the 10 meters per second speed. So the more speed you want to get, your distance covered would become squared. So if you want to double the final velocity, your distance covered will become 4 times. If you want triple the final velocity, your distance covered will become 9 times, and so on and so forth. Physical significance বুঝা গেছে?
Yes, sir.
আচ্ছা। Taisi, you asked me a question. Could you explain direct proportionality? What do you mean by that?
Sure. I mean, how the proportionality.
I explained direct proportionality in our last class. What does it mean? How to understand direct proportionality?
Sir, could you give me a small recap?
ঠিক আছে, direct proportionality of a certain variable actually means whenever you have two variables, let's say P and Q, they are related directly proportional. Directly proportional means if you want to take, let me just write a proportionality equation that looks like this. If we want to take out the proportionality sign, the typical way we go by this is that we take out the proportionality sign and we add P equals to K into Q, which brings us that P by Q should be a constant K. Now, what it means essentially is that no matter what values you pick out for P and Q for different individual scenarios, all the pair values of these two variables, P and Q, the ratio of these two values would be a constant number. So your numerical value for the ratio of P and Q for different individual pair values would always give the same value. So one easier, so this can be actually rewritten in terms of equation. Let's say P1 by Q1 equals to P2 by Q2 equals to P3 by Q3. If you have all of these individual pair values, the ratio of all of these things would be equals to that constant, proportionality constant. It can be better understood or better explained if we consider the scenario for graph. For example, if we have an equation over here, let's say if I want to give you an equation that's a straight line equation, let's say y equals to 2x, which means every value of y for a straight line that is represented by y equals to 2x line, every value of y would be double the value of x. So when x equals to 0, y equals to 0. Let me use blue. Let's say when x equals to 1, y equals to 2. When x equals to 2, y equals to 4. When x equals to 3, y equals to 6. X equals to 4, y equals to 8. So if we draw up a straight line just like that, this is the straight line that represents y equals to 2x. The property is that if you choose any random coordinate, not essentially the integer values, anywhere, if you choose any coordinate on this point, this straight line obeys the rule that its y value would be equals to double the number of the x coordinate. This is basically what we mean by direct proportionality, that if two variables are related like that they have a fixed ratio between them, then that's what we call directly proportionality. Now, one thing can happen that in many cases we can have squares involved. For example, the way we have involved over here, if you have a scenario, let's say, which shows you P square proportional to Q, that would simply mean that if you plot a graph of P square versus Q, you're going to get a straight line that passes to the origin. Not necessarily 45 degree, any straight line can be okay, because I did not scale this graph. So depending upon the scale, the gradient of this graph can be varied. So if you choose a small scale over here, your gradient is going to be pretty large, and vice versa. So as long as we do not actually put down numbers over here, like the way I did for the earlier graph, I actually plotted this thing, consider all the dot marks of the whiteboard. But as long as we do not give any scaling on the axis, we can actually just draw a straight line passing through the origin. That would be our graph for this thing. The shape of this graph and the shape of the other graph, I mean, for example, if I take a root over on both sides of this equation, if I root over this whole equation on both sides, so I can rewrite this proportionality as P proportional to root over Q. And this proportionality is also pretty much the same proportionality as this one, which means if I go ahead and plot another graph where on the y-axis we are going to plot root over P, and on the x-axis, sorry, my bad. On the y-axis we're going to plot P, on the x-axis we're going to plot root over Q. We're going to end up with the same straight line. But interesting information, if the gradient of this one is, let's say, m, the gradient of this line is going to be root over of m. That's the whole deal, because this straight line actually follows the equation P square equals to mq, and this straight line follows the equation P equals to root over of m into root over of q, because this is basically the root over expression of this original equation which was over here. So we root this thing, square rooted this equation to get this new equation. So this gradient would be different from the other one, but the shape of the equation would still be same. You would still end up with a straight line that passes to the origin. Makes sense? Makes sense?
So yes, sir. So the m is the constant here.
M in this case is the constant, which in the for the case of a graph, I'm showing this m as the gradient of the line, which within the equation is going to be the proportionality constant. For example, for the equation that we derived at the beginning of today's class, acceleration was considered as the constant. So if we're ever going to plot a graph of, let's say, v versus t for an object that starts from rest, you're going to get a straight line passing through the origin. The gradient of this graph is going to be acceleration, obviously. Then again, if you consider the third equation, if we plot a graph for positive acceleration object, if you plot a graph of s versus t squared, we're gonna get a straight line passing through the origin. The gradient of this graph is gonna be half a. Where did this half a come from? Right from here. Where is this? This half a comes from right over here. Have a look. Have a look at this expression. This is basically the y equals to mx equation that I wrote earlier. This is your y-axis variable, t square, all of it, not only t. This is your x-axis variable, and this whole box thingy is your m. So y equals to mx. That's your equation. So if you plot a graph of s versus t squared, you're gonna get a straight line that passes through the origin, for which half a is the proportionality constant. Does it make sense?
Yes, sir.
Clear hoise kina?
Yes, sir. Clear hoise.
Beautiful. Kids, any further question? I would like to take a good amount of time to explain these things to you. কারণ হচ্ছে proportionality concept গুলা হচ্ছে মানে baseline এর মতো. If you understand them properly, you can use them like anything, and things are gonna become easier. কারণ আমাদের এই proportional relationship সামনে আরো অনেকগুলো আসবে. আমরা এরপরে elasticity law, we're gonna learn in elasticity chapter that applied force is proportional to displacement. We're gonna go for graphs for that. We're gonna learn Boyle's law. We're gonna learn Ohm's law. So the idea of proportionality, inverse proportionality, they're gonna be part of our discussion by a lot. So as long as you understand these parts, things properly, it will be easier for you to handle those information. আচ্ছা, প্রপোর্শনালিটি অ্যাকচুয়ালি আরো অনেক ধরনের ভ্যারিয়েশন দেখানো যায়। আমি আপাতত সবগুলো ভ্যারিয়েশনে যাচ্ছি না। ইভেন্চুয়ালি যখন আমাদের রিলেভেন্ট টপিকে আসবে, তখন রিলেভেন্ট টপিকের জন্য দেখাবো। ফর এক্সাম্পল, ইনভার্স প্রপোর্শনালিটি গ্রাফগুলো দেখতে কিরকম হতে পারে, সেটার একটা ভিউ তোমাদের লাগবে। স্পেশালি ইন বয়েলস ল, উই গোনা নিড দ্যাট বিকজ প্রেসার ইজ ইনভার্স প্রপোর্শনাল টু ভলিউম। দ্যাটস দ্য বয়েলস ল। বাট ওটা অ্যাপ্রোপ্রিয়েট কেস যখন চ্যাপ্টারে আসবে, তখন আমি তোমাদের দেখাবো। নো ওয়ারিজ দেয়ার। আচ্ছা, আর কার কোনো কোশ্চেন? এনিওয়ান? নূর, জাহিন আবরার, মুহতাসিন, আয়মান, আফতাহি?
No, sir.
No, sir.
Awesome. Let's pick up the second question that we had in our homework the other day, and we go try that a little bit. Okay, question number 2 says a car starts from rest and accelerates uniformly at the rate of 3 meters per second square for 10 seconds. It then maintains a constant speed for half a minute. Then the brakes are applied, and then the vehicle uniformly decelerates in 8 seconds. Okay. A, find the maximum speed of reached in kilometers per hour. Sketch the VT graph, labeling all necessary values while doing any further calculations necessary. Using the graph or otherwise, calculate the total distance covered. I'm going to solve this whole problem for you part by part. If you have any question, you ask me in between, no problem for that. So this is question number 2. What are the values that we have? So first of all, we have that the object car starts from zero velocity. For the acceleration duration, we have an acceleration of 3 meters per second squared. We do not know the final velocity, but for this acceleration duration, the time requirement was 10 seconds. Then it maintains that constant speed for a certain duration for a half a minute. So I can write, let's say T1. This was for our, and I'm going to write this as A1. Let's say we're considering this for segment 1 and also U1. So segment 1 is the scenario where the object is actually accelerated, speeding up. So that's going to be our first set of observation. And then the segment 2 is going to be our constant speed, as the question says that it then maintains a constant speed. So I'm going to define this as S2 or U2, V2, T2, like that. That's the variables relevant for segment 2 is going to be 2 with all the suffixes 2. And the deceleration segment is going to be considered as 3. So we don't have any value for as part from the question for segment 2. So I'm just going to write up the over here that for segment 2 all that we have is that it maintains the uniform velocity for half a minute. Half a minute means half minute equals to 30 seconds. And then it says that then it breaks uniformly and decelerates in 8 seconds. So and decelerates to rest. Does it say decelerate to rest? I did not say decelerate to rest. Did I? Did I? Did I say decelerate to rest, or did I only say decelerates? বলো একটু দেখো তো বাকিদের কোশ্চেনে। Did I say decelerate to rest? Did I? I did not.
Yes, sir. You say decelerates to rest.
আচ্ছা সো এটা দিছিলা হচ্ছে কে জানো দিছিলা? আচ্ছা যেই দিয়ে থাকো একটু কারেক্ট করে নাও। It should be decelerates to rest হবে এখানে এই পার্টটুকু অ্যাড হবে। So what we know for the third segment that the final velocity for the third segment, so final velocity for third segment is 0, and we also know that the time requirement, which I should R2 লেখা possible. So final velocity for the third segment is 0, and the time it takes to for the third segment for the deceleration period that happens in a duration of 8 seconds. So এই ইনফরমেশন গুলো আমাদের কাছে আছে। সো আমি ফার্স্ট সেগমেন্টের গুলো ফার্স্ট লাইনে লিখছি, সেকেন্ড সেটের ইনফরমেশন গুলো সেকেন্ড রোতে লিখছি, থার্ড সেটের ইকুয়েশন গুলো মানে ইনফরমেশন গুলো থার্ড রোতে লিখছি। আমি ইচ্ছা করে এরকম ডিফারেন্ট ভাবে লিখলাম যাতে করে আমার পরবর্তীতে যখন আমি নেক্সট whenever I'm going to look out for the numerical values, I don't have a hard time finding out these numbers. I could have written all of these things in a single line, but I didn't do that. Intuitively, I wrote them in different rows so that I can find them out easily. So that's my data collection from the question, and then let's go for the question part by part. In question number 8 says find the maximum speed reached in kilometer per hour. So maximum speed reached means basically the final speed of the first segment, because you do understand the object is going to speed up to a final speed, maintain that final speed, and then drop from that speed. So it means the final velocity of the first segment or the acceleration segment is going to be our maximum speed. So I'm going to write v1 equals to u1 plus a1 t1. This is the same equation as v equals to u plus at, but I have written all the individual variables with numbers because I'm doing this for the first segment of the motion, the accelerating part. So let's go for replacing all these numbers. 0 plus 3 into 10 gives you 30 meter per second. So that's basically our answer, but we are not okay to write this because the question asked us to convert this thing into kilometer per hour. So we're going to go for that conversion. 30 into meter divided by second. So I'm going to write 30 multiplied by 1 by 1000 kilometer divided by 1 by 3600 second. Sorry, not second, my bad. Hour. So which ultimately gives me what do I get? Where's my calculator? দেখো তো কত আসে এটা 30 into 3600 divided by 1000. (108 kilometers per hour). Yes. So that's the answer. We're gonna need this number a lot, so I'm putting a bit of underline over here for the upcoming parts. That's for A. In number B it says, আচ্ছা বললাম তোমাদেরকে আমি কয়েকটা জিনিস একটু আলাদা আলাদা করে বলি, যেটা তোমাদেরকে আগে আমার বলা উচিত ছিল বাট আমি বলতে ভুলে গেছিলাম। সেটা হচ্ছে, let me show you a certain thing from the syllabus. আজকে কি বার? স্যাটারডে। তোমরা পরীক্ষা দিবা হচ্ছে কততে জানো? 23 না? ওকে, এটা তো লাস্ট পেজ, এটা না, এই যে এই জিনিসগুলা। আচ্ছা, এখানে অ্যাকচুয়ালি খুব অল্প একটু ডেসক্রিপশন দেওয়া আছে, এটার চেয়ে একটু বড় একটা ডেসক্রিপশন, এটা হচ্ছে তোমাদের সিলেবাসের ভার্সন, একটু বড়টা ডেসক্রিপশন দেওয়া আছে হচ্ছে লার্নার গাইড। লার্নার গাইড এখন এটা হচ্ছে মনে হয় নট দিস ওয়ান, এটা হচ্ছে মনে হয় রিসেন্ট লার্নার গাইড। এটা একদম লাস্ট পেজ, একটা দরকারি জিনিস আছে আমার এখানে, কার্সর কই, এই যে। আচ্ছা, I'm gonna give you this learner's guide. There are two different pages that you need to understand. দাঁড়াও, let me just show you how to find the learner's guide. 5054 learner guide. Boom. This is the syllabus, get description, syllabus update, and where is the learner guide? Sources. Nope. আচ্ছা, রিসেন্ট ইয়ার লার্নার্স গাইড দেখছেন, লার্নার্স গাইড আমি তোমাদেরকে পিডিএফ পাঠিয়ে দেবো, সমস্যা নাই। The reason I am actually here, actually আমি এটা পুরোটা একটা পেজে দেখানোর জন্য এত ঝামেলা করতেছি। আগে ইয়ারটাতে মনে হয় একটা পেজে পাবো, আমি পাবো কি না, এখানেও 2 পেজে দেওয়া। আচ্ছা, এনিওয়ে, what is really important, I'm gonna hand you over the learner's guide. Learner's guide কেমন করে ইউজ করতে হবে অ্যাকচুয়ালি পরীক্ষার সময় সেটা পরে বলতেছি, but at the end of the learner's guide you're gonna come across this table. These are common words and phrases. Whenever a question is given to you in a question paper, they give you a certain command word that calculate this, deduce this, define this, describe this, determine this, discuss this, and then estimate, explain, list, measure, outline, predict, sketch, state, suggest. What is meant, or what do you understand by? What should be your answer be like whenever you come across these different type of words? For example, how your statement of a certain answer is going to differ if you are trying to describe a certain thing and discuss a certain thing. What is the difference between these two words? I mean, you might find them not to be so different. What is the difference between defining a certain object and explain what is meant by a certain object or a certain concept or a certain definition? It is very important to be able to distinguish all of these individual common words so that you know exactly what your response should be towards that answer. This is important. So I'm going to give you this PDF. One homework for our next class is going to be, I want all of you to go through this table. If you are interested, you can read through the whole thing. It's not necessary for the time being. It actually put a syllabus last year. Learner's guide is basically required at the end of the syllabus, but I highly emphasize to go through this table and understand the meaning of each of these individual words before we pretty much at the beginning of the syllabus. So I want all of you to go through this material. This table and find out anything that you want to ask me about. So this is going to be a homework. I'm going to hand you over the PDF after the class. I'm going to share it in your messenger thread. বুঝছো কি বলছি? I'm going to ask about this and discuss about this in the next class. So this will be a default homework. আচ্ছা, এটা গেল। আচ্ছা, কেন আমি লার্নার্স গাইডে গেছিলাম? Because what I asked you over here, there is a certain word, it says sketch. Whenever you come across this word sketch within a certain question, it actually means that you are asked to roughly draw out the scenario, not with pinpoint accuracy. For example, they can ask you to sketch the diagram to measure the value of gravitational acceleration by an experiment. So you can either go for a dropping or falling object, you can go for a simple pendulum, you can have different type of setup to measure the value of G for appropriate scenarios. But what is important is that that's for the sketch idea. The other word that is also applicable for a graph question is they can also use plot. Now, important difference, you have to be able to distinguish between these two words. If they ask you this thing plot, this means you have to have a scaled diagram. Either the question is going to give you a graph paper and you are supposed to put numbers by actually plotting the values within this graph paper with appropriate scale on the x-axis and the y-axis, and by counting the squares and everything. Or if the question does not give you a graph paper but still ask you that you are supposed to plot a certain thing, in that case you are expected to draw up an axis system of your own, use your ruler and the centimeter mark over here to make up your own graph. You don't have to draw a whole grid, but you have to give equally spaced lines over here, an equally spaced line over here, and make up your own scale as per your requirement, and then plot the individual numbers by appropriate placing. Plotting means scale has to be there. An appropriate scale should be there. The scale should be properly marked and properly labeled and properly ratioed for the actual placement of all the individual coordinate points. Sketch, on the other hand, means this needs to be a rough edge, or in many cases I use the term figure not drawn to scale. That's basically what it means by a sketch drawing. For example, I can sketch the solar system like this. This is the sun, this is the earth. I can do this. Figure not drawn to scale. This is a sketch figure that sun is over here, earth is over here, this is the distance, earth is going around the sun in an orbit like that. This whole thing actually doesn't also mean anything. But if you're trying to plot, or I cannot use the term plot, if you're trying to draw the diagram of the solar system by scale, then it's going to be a mammoth task. Typically for those figures where the solar system is drawn to scale, it actually gives us a small peak like that, where the sun's radius is shown on the edge by a curve like that. This is the sun, and then the earth somewhat looks like this much size. So that's the difference between a sketch diagram and a plotted diagram, or where the scenario is considered to be within scale and not within scale. এই দুটো ওয়ার্ডের ডিফারেন্স বুঝা গেছে? প্লট এন্ড স্কেচের ওয়ার্ড মিনিং এর ডিফারেন্স বলবান? আচ্ছা, যদি প্রপারলি বোঝা না যায়, নো বিগ ডিল, এটা নিয়ে প্রেশান হওয়ার কিছু নাই। এটা আস্তে আস্তে তোমার প্র্যাকটিস করতে করতে আরো ক্লিয়ার হবে। Let me show you how to solve this problem to begin with. So I'm gonna erase all the stuffs over here because I'm not gonna need the whole scale thingy. Okay, because the question, I should also get rid of this part as well. Achha. Sketch the VT graph labeling all the necessary values with while doing any further calculation necessary. So we're going to draw the VT graph over here. Whenever you are sketching or plotting, it is important that you label the axis properly. So in this case, I'm going to label this as t/second, v/meter/second. So the object starts from rest. It accelerates for a duration of 8 seconds. So I'm going to label sorry, it exists for duration of 10 seconds. So I'm going to label 10 over here. And the final velocity that we calculate over here was 30. So I'm going to just give a mark over here, label 30. These are the sketch idea of a sketch graph, that you label all the necessary values, and the point is going to be somewhere over here. And this is going to be our accelerating duration. First segment of our journey. It is বুঝা গেছে কিনা? Over 10 seconds, the train is train or car. The car is achieving a final speed of 30 meters per second. I'm going through the discussion continuously. If you have any question, please raise your hand or ask me in the chat or just voice up. Anything works. I'm going to keep the chat window as well. Yes, right, Ryan, follow.
So for plot, so if the question is set to plot, would we have to sort of mark each individual points like 1, 2, 3, 4, 5, 6 all the way up
No. You don't have, you wouldn't have to mark every individual point, but you would have to mark the আচ্ছা ঠিক আছে, এই সেম কোশ্চেনটা যদি প্লট বলতো তাহলে কিরকম করে রাখতে হতো সেটা আমি একটু পরে তোমাদের দেখাচ্ছি, নো ওয়ারিজ, ঠিক আছে? এক্স্যাক্টলি সেম কোশ্চেনটা যদি প্লট বলতো তাহলে কিভাবে রাখতে হতো সেটা আমি একটু পরে দেখাচ্ছি আবার, so that you can compare between a sketch graph and a plot graph. No big deal, আমি দেখাবো। So this is that, and then the train goes for uniform velocity, maintains the uniform velocity for a duration of how much? That we picked up over here for 30 seconds, which means it maintains the uniform velocity for a duration of 30 seconds, which means from here up to 30 seconds, which means if we consider from 0 minute, this the end point of the uniform velocity, this is, I can actually give dotted lines over here just to make sure that the examiner knows what I'm doing. Dotted lines mean reference lines for the plotting help. Dotted lines don't mean actual line on the graph. So I can write over here 40. You should be careful that this should be 40. This should not be 30, because the train runs for a uniform speed over a duration of 30 seconds. So from the beginning, for this scale, this is 10 seconds and this is 40 seconds, so that the gap in between is 30 seconds. Then the question says that then the train decelerates to rest within a duration of 8 seconds. Now to draw this part up, I have to just draw a straight line starting from here, going all the way down over here, which should be within 8 seconds. So I don't actually have to do any calculation, because I do understand the time that is going to be labeled over here should be 48, and then I can simply draw it down. You should definitely use ruler. Don't draw graphs like me, like a hobo. I'm not hobo. I mean, that might be a bit racist. Don't draw graphs like a lunatic without straight for straight lines. Please use rulers. So this is how a sketch graph looks like. That's basically it. Now, if the question asked us to plot this whole thing, then we will have to do some pre-calculation. For example, if the same question was for a plot, then we will have to understand that the total duration of the journey should be 48 seconds, and on the y-axis, the total amount of vertical velocity or the rise of this thing in maximum value should be labeled as 30. So let's say no graph is provided for us. So how can we best accommodate this graph on a piece of A4 paper? So I don't actually have an A4 paper in my hand, exact dimensions, but simply speaking, you are trying to represent this graph, which should look like this. So on the horizontal axis, you should need to accommodate at least 48 values. So a convenient number to go for the whole line might as well be showing up to 50 seconds or maybe up to 60 seconds. Now, what would be a convenient distance on your ruler to choose for 60 seconds? Can you choose 60 centimeter horizontally? You cannot. Your page is not that wide. Can you choose 30 centimeter? Have a look. Give it a try. If you have a piece of paper in your hand, whatever the piece of paper that is, standard piece of paper, and put up your ruler across it, see if you can accommodate 30 centimeter or even 25 centimeter would work. Can you accommodate 25 centimeter? I bet you cannot.
No, sir.
You cannot. So a logical way to accommodate 48 might actually, I mean, we are trying to accommodate 48 seconds. So I am trying to recommend that we are gonna plot this graph up to a value of 50 seconds, or maybe at maximum 60 seconds. So what do you think would be a convenient length of this horizontal x-axis, so that we can give uniform spacing so that we can actually accommodate 60 seconds? What length do you recommend? I mean, we cannot go for 60 centimeter, for which you could be 1 centimeter for one second. we cannot go for 30. The next variation is actually 15 centimeter. You can go for 15. Think about it. I'm actually ratioing it by half. I'm just making the number half because that actually gives us a large advantage that the whole calculation remains pretty simple. I'll show you how. If we choose the line of the horizontal axis length to be 15 centimeter, where each centimeter, where the total 15 centimeter line, I mean, you don't have to understand. I have to understand. Let's say over the 50 centimeter line, I want to plot 60 seconds. So 1 centimeter should be responsible for how many seconds? Unitary method, kids. 4 seconds. Beautiful. 1 centimeter should be representing 4 seconds. So that would mean that if I can, and 50 centimeter is a line that you can definitely accommodate within your page horizontally. You have that much space. So I'm going to choose to draw a 15 centimeter line over here, or maybe slightly bigger than 15 centimeter, because I'm saying slightly bigger, because I would appreciate to write 60 over here. And here I should have t seconds. So the total length of the line starting from this point all the way up to the tip of the arrow should be slightly bigger than 15 centimeter, but the actual length from this point all the way to the 60 second mark, this much should be exactly 15 centimeter. এখনই 50 সেন্টিমিটারের মধ্যে তুমি আস্তে আস্তে লেবেলিং করো। কিভাবে লেবেলিং করবা? তুমি 3 সেন্টিমিটার পর পর ডট দিতে পারো, সেক্ষেত্রে তোমার 5টা ডট আসবে। আর তুমি যদি 3 সেন্টিমিটার, ফর এক্সাম্পল, if you want to label this at 3 centimeter apart, then every 3 centimeter, I mean, would be how much? 12 seconds, right? Think. If you want to give marks after every 1 centimeter, আচ্ছা আমি বুঝাই আমরা মার্কিংটা কেমনে করবো সেটা আলাপ করতেছি। সো আমরা যদি প্রত্যেক সেন্টিমিটার পর পর একটা করে মার্ক দেই, তাহলে আমাদেরকে মোট 15টা মার্ক করতে হবে। সো I'm gonna have 4, 8, 12, 16, 20, blah 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 blah, it goes on। ঠিক আছে, এখন কথা হচ্ছে আমরা এতগুলা ইন্ডিভিজুয়াল মার্কিং দিব কিনা। আনসার হচ্ছে না। গ্রাফ প্লট করার সময় কখনোই আমরা এতগুলা ইন্ডিভিজুয়ালি কি লাগবে? আচ্ছা, আমরা কোনো সময় গ্রাফ প্লট করার সময় এতগুলা ইন্ডিভিজুয়াল মার্কিং দিব না। So we're gonna choose a convenient number of plotting points and we're gonna do it smartly. For example, if I give for 50 centimeter, if I mark out the 5 centimeter length, let's say this is my 5 centimeter length. So I'm gonna write the centimeter values over here, which you are not gonna write on your graph, but I'm just writing this thing to give you an idea what I'm doing here. Let's say this is my 5 centimeter mark, and this is my 10 centimeter mark, and this is my 15 centimeter mark. You're not gonna write these centimeter marks. I'm just writing this thing to show you what levels should you mark. So if this is 60, this is gonna be 20, this is gonna be 40, and this is gonna be 60. So this is actually only 3 marking, but this many few markings on a plot graph is usually not recommended. So what we should do on the piece of white paper, we can also find out their halfway point. So let's say this is gonna be my 2.5 centimeter, and which is gonna be 10 second. This is gonna be my 7.5 centimeter, which is gonna be 30 second. This is gonna be my 12.5 centimeter, which is gonna be my 50 second, and that's a good axis. So whenever you're trying to plot a graph, it's important that you understand the limitation that you have or the space that you have, and plot that out with a convenient number so that the plotting becomes easier for you. And আমি যদি এখানে এই রেশিওতে না গিয়ে যদি একটা মানে if I want for a difficult to work with number, for example, let's say if I wanted to draw this line to be maybe, let's say 17 centimeter line, I want to represent the whole thing with the 17 centimeter because I have available 17 centimeter space within my margins, and I want to represent 17 centimeter for 60 seconds. This ratio would be very difficult to work with, right? Because the numbers are really not into each other. I mean, one of the number is not a product of the it's not a product. What is it called? উৎপাদক কে জানি ইংলিশে কি বলে? I forgot this English terminology. Oh my god. What do you call this number? 6 equals to 1 into 2 into 3. What do you call this 1, 2, and 3? এগুলো জন্য কি বলে?
Factors.
বুঝি নাই।
Factors.
Factors, right. So because 17 is not a factor of 60, so having a scale like that would prove to be mammothly difficult to actually get appropriate plotting. So plotting এর কাজ দ্বারা বুঝা গেছে কিনা? মানে মেথোডোলজিটা বুঝা গেছে কিনা? It's always recommended that you choose a good number of multiples so that you can space it out easily. So ultimately আমাদের গ্রাফটা হবে হচ্ছে এরকম, এক্সিসটা হলো এরকম, ওইদিকে উপরে ভার্টিক্যাল এক্সিসের জন্য 30 সেন্টিমিটার জন্য তুমি যে কোনো অ্যামাউন্টের লেন্থ চুজ করতে পারো, যে কোনো অ্যামাউন্টের লেন্থ চুজ করতে পারো। সো ইফ ইউ আস্ক মি, আই এম গোনা গো ফর a 5 centimeter length over here, and I can actually choose to label all of the 5 centimeters. So let's say 10, 20, 30, 40, 50. If you choose that, স্যার আমি 50 বন্ধ কেন, আমাকে তো 30 বন্ধ আঁকলে হতো, হ্যাঁ ঠিক আছে, কোনো সমস্যা নেই। তুমি 30 বন্ধ আঁকলা, তার উপরে অ্যারো দিয়ে দিছো, কোনো সমস্যা নাই, আঁকতে পারবা। তুমি 3 সেন্টিমিটার চেয়ে একটু বেশি আঁকো, যাতে করে অ্যারোটা তুমি অ্যাকোমোডেট করতে পারো, and then you simply write meter per second, and that's basically your plot. And then you have to slowly go forward to draw your value. So এখানে আমাদের ভ্যালুগুলো কিরকম আসবে? Let me, if I try to plot this number, within the first 10 seconds, the train speeds up to 30 meter per second. So it means this will be one of our points. So I'm going to draw a straight line right over here. That will be maintained all the way up to 40 seconds. Now comes the point where we have to measure appropriately 8-second time, because the next duration should be 4 seconds. Now remember, এখান থেকে এইটুকু কত সেকেন্ড টোটাল? 10 সেকেন্ড না? বলুন বুঝো, এখান থেকে এটুকু পুরোটুকু কত? 10 সেকেন্ড। তোমার দরকার কোথায় ক্রস করা? তোমার ক্রস করার দরকার হচ্ছে 48 এ, ঠিক না? and 48 টা এক্স্যাক্টলি কতটুকু লেন্থ হবে এটা আমরা কিভাবে বুঝবো? Pretty simple. Just try to have a look over here. How much physical length did you have? You had a length of 2.5 centimeter for 10 seconds. You want to find out how much should this be for 8 seconds. So I'm going to go for unitary method. 10 seconds is represented by 2.5 centimeter. So 1 second, 8 second. 8 second will be given by 2.5 divided by 10 into 8. How much do you get from here? দেখো তো কত আসে? 2.0 আসার কথা মনে হয়। 0.5 into 4. হ্যাঁ, 2.0 সেন্টিমিটার আসছে। বলো মানে রেসপন্ড। 2 সেন্টিমিটার আসে, 2.0 সেন্টিমিটার। তার মানে হচ্ছে you didn't know how much you have to go. For example, for all I care, এই স্কেলটা আমাদের 47 সেকেন্ড হইতে পারতো। মনে করো আমি লাস্টের ভ্যালুটা বলছি হচ্ছে it then moves by 7, it decelerates for a duration within a duration of 7 seconds. তখন তুমি সিম্পলি কি করতে? এখানে 7 সেকেন্ড হিসাব করে দেখতে কতটুকু আসে, যা আসে এটাকে রাউন্ড অফ করতে close to the 1 decimal place for the centimeter, because your meter rule can give you fractions of 1 centimeter. You can, so এবং এরপর তুমি জাস্ট এখানে রুলার ধরে এক্স্যাক্টলি 0.8 সেন্টিমিটার বা 8 মিলিমিটার পর একটা ডট দিবা, এবং এখান থেকে, এবং এই ডটটাকে তুমি আর লেবেল করবে না, because once you have labeled the whole axis, you don't have to dot the individual dots. Just give a line over here just like that I have given, and complete your plotting graph just like that. That's how the plotting is done. That's the difference between a plot graph and a sketch graph. দেখো বুঝা গেছে কিনা? প্লটিং করার সময় স্কেলিংটা মাথায় নিতে হয়, অ্যাপ্রোপ্রিয়েটলি স্কেলিং করতে হয় এবং ভ্যালুগুলো সবগুলো অ্যাপ্রোপ্রিয়েটলি বসাইতে হয়। আর স্কেচ করার সময় জাস্ট বসাইতে পারলেই হয় এবং রিলেভেন্ট ভ্যালুগুলোকে প্রপারলি লেবেল করতে হয়। দেখো এখানে আমি লেবেল করছি 10, 40 আর 48, বাট এখানে লেবেল করছি হচ্ছে অ্যাকচুয়ালি একটা স্কেল, ইউনিফর্মলি ইনক্রিজিং একটা স্কেল। Does it make sense so far?
Yes, sir.
So এটা গেল। It was a good question that I actually got to show you what the plotting would mean. Then the question says that sketch the VT graph of labeling all the necessary values while doing any further calculations. So to do this graph, we actually didn't have to do any further calculation. All that you have to do was to add up the numbers of the second. So you don't actually have to show that, not necessary. Number C, it says using the graph or otherwise calculate the total distance covered. So finding out the total distance covered using the graph would be very simple, because this is a very beautiful trapezium that we have, where this side has a length of 30, the bottom side has a length of 48, the height is 30. So I can go by half into 30 plus 48 multiplied by 30, whatever you get, it's gonna be 78 into 15. 1170 meter. So that's basically your total distance covered. Very easy to find out from the graph. If we want to go for the alternative method, the question actually asks you that find using the graph or otherwise. So if you find it by the graph, which is perfectly all right. But if you want to find it for the by the alternative method, I'm gonna show you that as well. So finding out in the alternative method is also pretty simple. For example, S1 would be equals to 0 plus 30 divided by 2 into 10. You calculate that. S2 will be equals to 30 into 30. You calculate that. S3 equals to 30 plus 0 divided by 2 into 8. Calculate that. তো আমি বুঝছো এখানে কোন ইকুয়েশনগুলো ইউজ করছি? বলবান? This was equation number 2. I discarded the acceleration altogether from the equation. I didn't bother to calculate the acceleration. So u plus v divided by 2 into t. This was uniform motion, so s equals to vt. So only the speed into time, it just happens to be equal for both these values. And then for the third segment, initial plus final velocity divided by 2 into t. So এখান থেকে কত আসবে? এখান থেকে আসবে হচ্ছে 30 into 5 150, এখান থেকে আসবে হচ্ছে 900, এখান থেকে আসবে হচ্ছে 120. If you add all these three, you're still gonna get 1170 meters. So if the question didn't ask you to draw the graph, let's say the question only gave you these numbers and asked you that find out the total distance covered. In that case, drawing a graph would not be a good idea. Actually, you can draw the graph if you want, just because it's easy to find out the area uh, uh, from a graph. But if you want to skip drawing the graph, if the question doesn't ask you to draw a graph, you don't have to draw a graph. But if you choose to draw a graph, you can draw a graph. That's my point. That's my point. So if you don't want to draw the graph, but the question didn't ask you, but still want to find out the total distance covered, this is your method, that you find out the individual distances for individual segments of acceleration, different acceleration, and then add up them all together to get the final value. Make sense? I hope.
Sure.
Acha. আরেকটা কোশ্চেন লেখো, বলতেছি আমি। Should I go for all of these questions or some of these questions? This is actually a pretty nice thing. ওকে লিখো, বলতেছি। A train 100 meter long stops in a station with its front bumpers in line with the lamppost on the platform.
Sir, could you repeat the question again?
Yes, a train 100-meter long stops in a station with its front bumpers, basically it means front end, with its front bumpers in line with the lamp post on the platform. In line with the lamp post on the platform. Full stop. Later, it starts off with an average acceleration of later it starts off with an average acceleration of 0.6 meter per second squared. Later it starts off with an average acceleration of 0.6 meter per second squared. Full stop. What will be the speed of the train what will be the speed of the train when the tail bumpers pass the lamppost? What will be the speed of the train when the tail bumpers pass the lamppost? The question number 1 উপরে আজকে ডেট দাও। Number 2, a projectile is fired vertically upwards. A projectile is fired vertically upwards and reaches a height of 125 meter. Reaches a height of 125 meter. Full stop. Find the velocity of projection. Find the velocity of projection. Velocity of projection means initial velocity or throwing velocity. এটা লেখা লাগবে না, আমি জাস্ট বোঝানোর জন্য বললাম। Find the velocity of projection and the time it takes to reach back to Earth. Number 3, the valve of a cylinder the valve of a cylinder containing 12 kg of compressed gas the valve of a cylinder containing 12 kg of compressed gas is opened and the cylinder empties and the cylinder empties in 2-minute time. 2-minute time. The average velocity of exhaust gas is 25 meter per second. The average velocity of exhaust gas is 25 meter per second. Full stop. Find the force exerted on the cylinder. Find the force exerted on the cylinder. এরপর কোশ্চেন দেখো নাম্বার 4. A breakdown truck basically means a tow truck which takes a vehicle when they are not running anymore. A breakdown truck tows a car of mass 1000 kg. A breakdown car tows a car of mass 1000 kg along a level road.
So could you repeat?
A breakdown truck tows tows a car of mass 1000 kg along a level road. And accelerates at 0.5 meter per second squared. And accelerates at 0.5 meter per second squared. What is the tension in the tow line? What is the tension in the tow line? Comma, if road friction is 500 Newton. নিচে প্যারাগ্রাফে লিখো, this is the second part of the question. আমি ভুলে এ বি লিখতে ভুলে গেছি। কে যেন হাত উঠাইছো? রায়ান বলো।
Sir, could you repeat the last line of number 3? Sorry, the line before the last line of number 3.
Number 3.
Yes, sir.
Number 3 জানি কোত্থেকে দিছি। Number 3 এর লাস্ট লাইনটা ছিল হচ্ছে find the force on the cylinder.
Sir, the line before it, the average velocity.
Average velocity কত বলছিলাম ভুলে গেছি। Can someone else tell me? Exhaust velocity কত বলছিলাম? Was it 30 meter per second? 25. Can someone tell me what was the exhaust velocity for number 3? Please.
25 meter per second square.
No. Exhaust velocity cannot be 25 meter per second squared. Exhaust velocity is 25 meter per second.
Oh, sorry.
It's okay. No big deal. If the exhaust velocity of the cylinder is of the gas is 25 meter per second, find the force exerted on the cylinder. 25 meter per second. আচ্ছা, আমি নাম্বার 4 এর কোশ্চেনটা অর্ধেক বলছিলাম। সেটা হচ্ছে the first part was that what is the tension in the tow line if the road friction is 500 Newton. That's the first part. নিচে প্যারাগ্রাফে লিখো, the tow line breaks the tow line breaks when the truck and car both reach a speed of 36 kilometers per hour. The tow line breaks when the truck and car both reach 36 kilometers per hour. Full stop. How far will the car travel before coming to rest? How far will the car travel before coming to rest? If a braking force of 5,000 Newton is applied. If a braking force of 5,000 Newton is applied. The question of meaning হচ্ছে when the car was being towed, there was someone sitting in the car as well. So even though the car was incapable to move, that's why it was getting towed. But when the tow line did break, the person who was sitting in the car was applying brakes. So you need to understand that there is a braking force of 5,000 Newton as per the question, which was newly generated from the braking mechanism of the car, and the default road friction was 500 Newton. So a total of 5,500 Newton would be used for the deceleration process. So keep that in your mind.
Sir, could you repeat the question number 5?
I did not say number 5 yet.
Sir, so the last part of question number 4.
The last part of the question number 4 is that if the tow line breaks, the tow line breaks when both the truck and car reach a speed of 36 kilometers per hour. Full stop. How far will the car travel before coming to rest if a braking force of 5,000 Newton is applied?
It's the braking force of
5,000 Newton, 5000 capital N, 5,000 Newton is applied. আরেকটা কোশ্চেন লিখো number 5. A bullet of mass 6 gram, a bullet of mass 6 gram, 6 small g, don't write in whole words, 6g, bullet of mass 6 gram, traveling at 120 meter per second. A bullet of mass 6 gram traveling at 120 meter per second hits a target and penetrates into the target while coming to rest within 0.05 second, while coming to rest within 0.05 second. Full stop. আমি আবার বলতেছি, a bullet of mass 6 gram traveling at 120 meter per second hits the target and penetrates into the target while coming to rest within 0.05 second. Full stop. Calculate colon নিচে লিখো a calculate a the distance of penetration into the target the distance of penetration into the target. Stop. B average retarding force working on the bullet. Average retarding force working on the bullet. লেখা হয়েছে?
Yes, sir.
ঠিক আছে, এই কোশ্চেনগুলো তোমার ট্রাই করবা and try to write them up in clearly understandable way. Is this একটা জিনিস তোমাদেরকে বলি বলমান, these homeworks are not a test. ঠিক আছে, I'm not going to judge your capability to understand or be able to interpret what I just taught you from the performance of your homeworks. No, I'm not going to do that. I'd rather do this. How much can you solve these questions with appropriate capability is a reflection of how much could I transfer the ideas into you, number one, and number two, how much could you actually put it into use based upon what you could learn within these classes. So তোমরা যদি কম পারো, the blame is equally mine. So I take responsibility for my doing. So my request হচ্ছে যে তোমরা ম্যাথগুলি ট্রাই করো, পারতেই হবে, কারেক্টলি পারতে হবে, কারেক্টলি না পারলে স্যার রেজাল্ট বলা যাবে না, বাকি সবাই কি মনে করবে। there is no such thing. This is not the actual CI exam. তোমরা ক্লাস করতেছো শেখার জন্য, এবং অ্যাটেম্প করলে ভুল হবেই, ভুল হওয়া ছাড়া মানুষ নাই। ঠিক আছে, সো দুই টাইপের পিপলের মানুষের ভুল হয় না, একটা হচ্ছে গড লেভেল পিপল যাদের ভুল হয় না বিকজ দে আর গড লেভেল পিপল, আর একটা হচ্ছে অলস টাইপের পিপল যারা কোনো হোমওয়ার্ক করে না বা কোনো কিছু করে না, সেজন্য তাদের ভুল হয় না, কিছু করে না, সো ভুল হওয়ার কোনো চান্স নাই। ডোন্ট বি দ্য সেকেন্ড টাইপ অফ পিপল, ডোন্ট বি। অ্যাটেম্প করো, যদি ভুল হয় আই উইল হেল্প ইউ টু আন্ডারস্ট্যান্ড দিস থিং, কোথায় ভুল হয়েছে, কেন ভুল হয়েছে, সেটা আমি তোমাদের ক্লিয়ার করবো। সো ইটস ইম্পর্টেন্ট দ্যাট ইউ ট্রাই। এই হোমওয়ার্কগুলো ট্রাই করো, এবং এই হোমওয়ার্কগুলো ট্রাই করার আগে তোমাদের একটা ডিফল্ট হোমওয়ার্ক আছে, সেটা হচ্ছে আমি যে পিডিএফটা দিব লার্নার্স গাইড, ওইটার লাস্টে যে হেডিং গুলি আছে হেডিংগুলি পুরোটা পড়বা, পার্ট বাই পার্ট পড়বা, and then if you have a printer, access to a printer, print out the last 2 pages so they are on both sides of the of a single page, and you can mark on that as well. And we're going to discuss about that table first in our next class, and then we're going to pick up these questions later on. And if this once we done these 2 things completely, then we're going to get back to our regular worksheet solving processes. That will be all for today's class. Polaman, thank you very much. If you have any question, I'd like to answer that, or we'll call it a day. কার কোনো question আছে? No. Assalamu alaikum.
Walaikum assalam, sir. Allah Hafiz.